All right, everybody, so here's a continuation of lesson number 1 from yesterday. We're going to talk about the last couple questions here, and I'm going to go through some of the homework questions with you. Again, like I said, if you want to, you can pause this, rewind it, watch it again this way. If you're missing anything or you just want me to clarify anything, you kind of go over through that. So here for this first question, it says, consider the graph of y equals f of x graph below. So remember, f of x is just a notation for the function. So here we have a function. We know that this is a function because it passes the vertical line test, meaning all of the x values are unique, so there's no duplicated x values. It then says explain why f negative 1. So f negative 1, what that means to us is this is talking about the inverse. So it says to explain why f negative 1 of x is a function and the graph f negative 1 and to graph the function f negative 1 of x. So to explain why this is a function, we have to look back at the original function f of x. So not only is f of x a function, it's also a special type of function called a one-to-one function that we talked about at the beginning of this lesson. We know that this is a one-to-one function because it passes the horizontal line test. If you were to draw a horizontal line anywhere through this graph, it would only cross the graph once, meaning all of the y values are unique. So what we can say here is that f negative 1 of x, I'll change that f because it looked ugly. So f negative 1 of x is a function because the original function f of x is 1-to-1. Then it asks us to actually go through and sketch the graph of this function. So to sketch the graph of this function, I'm going to take all of these points. So it gives us 4 key points. And I'm going to take those 4 key points and I'm going to switch the x and the y value. Because remember, to find an inverse's function, we're just going to reflect it over the line y equals x. So this first point is 4, 1. So if I switch that, it's going to become 1, 4, which is here. Oh, sorry. Negative 1. So it's 4, negative 1, so it's going to become negative 1, 4. So it would actually be here. The next point that we have is negative 1, negative 2. So if I make that negative 2, negative 1, we'd be here. The next point I have is negative 4, negative 3. So if I make that negative 3, negative 4, we'd be here. And the last point I have is negative 5, negative 4. So if I make that negative 4, negative 5, my graph would be here. So we can see it kind of looks the same. We're just kind of reflected it a little bit. So our graph looks something like that. And then we could go through and label, we'll call this f, and we'll call this f negative 1. All right, the next thing that it asks us to do is to state the domain and range of the function f. So that's the original graph, the graph that's in black here. So the first thing we want to do is we want to find the domain. So if we want to find the domain, we have to think of the possible x values that are on this function. So an easy way of doing this would be to set up like a table of values. So I'm going to have here an x value and an f value. So the 4 points that are given, including this first point and last point on your function, we have negative 5, negative 4. We have negative 4, negative 3. We have negative 1. We have negative 1, negative 2. And we have 4, negative 1. So for this function, the possible x values that I see are anywhere from negative 5 to positive 4. So my domain is going to start at negative 5 and go up to positive 4. Notice I'm using brackets here because I'm including those points because they're actually on my graph. The next thing we can find is the range. So the range are the possible y values. So the possible y values start at negative 4 and go up to negative 1. So the range is going to be from -4 to -1. Notice I'm going in order from least to greatest. Don't let that get confused. Now the next thing we have to talk about is going to actually be our domain and range of the inverses graph. So if I make a quick table of values for the inverse, there are going to be these same values that we had for f, just backwards. So it would be -4, -5, -3, -4, -2, -1, and -1, +4. So if we look at the domain now is going to be from -4 to -1, and the range is going to be from -5 to +4. And I'm hoping, as you're doing this with me, you're noticing something here. So I'm hoping that you notice that the domain and range kind of just flip-flopped. And that's what they're actually asking you to do in question 5, is to describe the relationship between a domain and range of a function and its inverse. So what we can say is the domain of a function is the range of its inverse. I can also say the range of a function is the domain of its inverse. So they kind of just switch. All right. Last question kind of takes us to something we did in a previous chapter, trigonometry, and kind of explains something that we're now doing in this chapter. So it says, is the inverse of y equals cosine of x a function? So what this is really asking us, is the cosine of x 1 to 1? That's all it's really asking. So if we look at the graph of cosine, so if I was to just sketch a quick cosine curve, I know the cosine curve looks something like that. Now, I know this graph is a function because it passes the vertical line test. But I know it's not a one-to-one function because it fails the horizontal line test. So I can say the inverse of y equals cosine of x is not a function because y equals cosine of x is not 1 to 1. So there's your notes. Now at this point I'd want you to start trying your homework problems on your own, and I'm going to do them for you here, so you should probably pause the video here if you want to try them on your own. I'm hoping that you are able to do some of these on your own. Okay, so at this point you've probably tried your homework questions. I'm hoping at this point you can now check your work, or if you're having trouble with them, you can use this video to kind of help explain what the homework answers should look like. So for number 1, it asks us to graph the function f of x equals 2 to the x power. So if you put that in your calculator, you're going to see all of these points that I'm labeling for you, and you're going to see a graph that looks something like this. I will label this f of x. Now if you notice, I've labeled 4 key points. Those are 4 points that have whole number values, and I can use those points in my table. So if I have x compares to f, I have 0, 1, I have 1, 2, I have 2, 4, and I have 3, 8. Now those points are going to help me graph the inverse, because if I want to graph the inverse, I have x and the inverses values. That's going to become 1, 0. It's going to become 2, 1, 4, 2, and 8, 3. So if I graph that, I have 1, 0. I have 2, 1. I have 4, 2. And I have 8, 3. Now, the original function, f of x, if you look, it comes down towards the x-axis and it approaches the x-axis and never touches it. Well, if I take the inverse, this graph is going to start by coming towards the y-axis and just never touch the y-axis. So we could see that the asymptote line also kind of flip-flops. So for f of x, the asymptote line was y equals 0. For f negative 1 of x, or the inverse of f of x, the asymptote line was x equals 0. So they kind of switch. Now, I didn't ask you that. That's just kind of extra info. You just had to sketch the graph. Then it says to explain why f of x equals 2 to the x has an inverse, and that's because f of x is a 1-to-1 function. And remember, a 1-to-1 function means that the x and y values are unique. So anytime we're asking if something has an inverse at the function, it's always just asking whether or not the function is 1-to-1. Now, why do I know that that is 1-to-1? Well, that blue graph that I have there passes the horizontal line test. All right, so if we go on to number 3. Number 3 says, does the function h of x equals negative absolute value of 2x minus 1 plus 4 have an inverse? Explain your reasoning. Now, the first thing we have to do to be able to complete this question is actually graph this function. Now, for those of you that don't remember how to graph an absolute value function in your graphing calculator, you have to remember the buttons to get to the absolute value brackets are math, and then you have to go over and then look for ABS with a parenthesis. Now, I'm going to graph what this looks like. I'm just going to use Desmos because that's what I can use here on my computer. All right. So if I go to Desmos here, so we want to graph this function. So I want to plug in y equals, and it was negative, right? So it's negative absolute value of 2x minus 1 plus 4. So here's what our graph looks like. So we see it's a true absolute value graph where it comes down to it has a point or vertex. We notice that this graph does not pass the horizontal line test. So because it does not pass the horizontal line test, it's not a 1-to-1 function. So that means it does not have an inverse. So the answer to this is no. And the reason is because h of x is not 1-to-1. Right? So it does not have an inverse function. Number 4, assume that g is an invertible function, meaning has an inverse. If point 73 lies on the graph of function g, what point must lie on the graph of the inverse of g? Well, since these two functions are inverses, I know that inverses switch x and y. So I know the point 37 is on g negative 1. It has to be, because the point 73 is on the actual function. So its inverse, which means flip the x and y values, would have to be on its inverses function. Last question on the homework. So the last question on the homework has us take this original graph, which they're calling the function h of x, and graph its inverse. So if you look at your graph, you have 1, 2, 3 points. So the first point is negative 7, negative 5. So if I graph here, make a little quick table of values. So I have negative 7, negative 5. I have a point 1, 3, and I have a point of 7, 5. All right, so if I want to find the inverse of this function, I just have to take these 3 points that they've provided me and switch them. So I'm going to call the inverse h negative 1 of x. It's telling us that we have an inverse, so we know it's going to be a function. I know that because of what it says right there. So if I take the point negative 7, negative 5, and make it negative 5, negative 7. So go negative 5, negative 7 is going to be down here. The point 1, 3 and make it 3, 1. 3, 1. I know those 2 points connect. And the point 7, 5 becomes 5, 7. So if I go 5, 7, I know those 2 points connect. So we see we have our inverse. Then it asks us to state the domain and range of h and the domain and range of h negative 1. So the domain and range, let's see. So if I want to find the, So if I want to find the domain of h, the domain of h, I can get right from this little graph here, or this table of values. The domain starts at negative 7 and goes up to positive 7, because the domain is the x values. The range, well, those are going to be your possible y values. So the range of h goes from negative 5 to positive 5. And once you know the domain and range of a function, you don't really have to do much to find the domain and range of its inverse, because you know the domain and range just kind of switch places. So the domain of the inverse graph is going to become negative 5, 5, and the range of the inverse's graph is going to become negative 7, 7. Notice both of those are brackets because both of these have points that are actually on your graph. I hope this helps. If you have further questions, please come and see me. Again, remember, all of this comes back to just the concept of switching the x and y values. That's the big concept here in this lesson. Good luck.